Yeah, okay. So, hello everyone. Am I audible, right?
Yes,
Yes,
sir.
sir.
Yeah, okay. So, in the yesterday session, I think Venkatesh has explained the whole week 7 content, and so you can watch that live session. So, today we are going to discuss the activity question and practice question. Okay. So, at first, yes,
Sequence parts are left, sir.
okay. Limit of sequence.
Yes, sir. And
Okay.
limits also, sir.
Okay. So, at first, we'll start with the limit and then we can go for activity question, right?
Yes, sir.
Okay. So is my screen is visible?
Yes, sir.
Yes, sir.
Okay. Okay. So tell me, what do you understand by limit? So when I say limit x tend to a for f of x, what does this mean? Does anyone?
Limit
Uh,
function value goes
Limiting
from
value of
1
x.
only to
A,
a.
A is in the domain of this function.
Okay. Yeah. So as x tends to a, what will be the my function will tends to, right? What particular value with my function will reach at when x tends to a, right?
Mhm.
So what particular value my function will reach? So that is basically a limit, right?
Hmm.
So say for example, I take f of x as x, right? So I can plot this like this. This is x, this is y, and this is right, y equals to x. Right now, say suppose this is point 2. Now I want to find out the limit when x tends to 2, what will be the value of this particular f of x, this function? So as my limit x tends to 2, so I want to reach this particular value too. So I want to find out the value of x at particular limit, right? What it will reach, right? So how I can go, right? So I can go from this side also and from
From
this
right
side
side,
also.
from left side, both sides.
So I can reach this two from this side also and from right side also,
Yes.
right? So in order to limit exist, there should satisfy two conditions, right? So first one
Hmm.
is our left hand side and right hand side limit should exist. And second, left hand side limits must be equals to right hand side limit.
Yes.
Right.
Hmm.
Okay. So okay, this is one simple. Let us take one different example. Okay. So for example, f of x is equals to x square minus 9 upon x minus 3. Okay. So this function is not
Yes.
defined at x equals to
3.
3. So
Hmm.
if I say x tends to 3, limit x tends to 3, and this x square 9 minus 9 and upon x minus 3. So when x tends to 3, this my function is not defined, right? But
Right.
as x approaches the 3, so what will the value of f of x here?
Then
So
we
that
have
we
to
have to
just
find out.
calculate that thing. X plus 3 or x minus 3, then cut it off, then x plus 3, it will be 6.
Yeah, so I can say, right, x square minus 9 as x square minus 3 square. So I can
Yes.
write it as x minus 3, x plus 3 upon x minus 3. So this will get cancelled. So limit x tends to 3, x plus 3, right? So when I put x here, value of x here, it will be 6, right? My function is not defined at x equal to 3. But when this x will tends to 3, our function value will reach to 6, right? So if I
Yes,
say
sir.
what will the value of 2.9 here? A function is not defined at x equal to 3, but I can take 2.991 or anything, right? It is
Tends
defined
to
at,
0.
yeah, no.
No, no, no.
So as x tending
In
to 3,
uh,
value of f of x will tend to 6, right? Here.
yes. Yes.
You can also solve, like if you put x 2.9 x square minus 9 upon 2.9 minus 3. So it will give you something 5.9 something. You can try out, right? So
So,
as
okay, yeah. Hmm.
So as my x tends to 3, say 2.99991, the value of f of x will tends to 6, right? Here
Nearby 6.
2.999.
Yes, sir.
Yeah.
Yes,
So
nearby
that is
6.
basically limit. Since here my function is not defined for x equal to 3, but still I'm getting the value of at limit x when x tends to 3, my function will tends to 6, right? So this is basically a limit. And remember one thing, like limit x tends to a, f of x is not equals to f of a. Right here you can see, if I put x equals to 2, it is not defined. But when I calculate the limit, it is giving 6, right?
Not every time. Or never.
No, not every time.
Okay.
Yeah. So for this condition, you can say, right? Yeah.
Can I
So-
say like that, sir? After simplification, we can put the limit value like 3.
Yeah. After simplification, we can put, because if you
We
put
can
here
put.
3, you will get 0 by
Yeah.
0, right? That is indeterminate form.
But when I suppose if I am not simplify it, just I put between 1 to 3. Suppose I put value 2. That answer will be correct or wrong if I put like.
Yeah, you will get f of
If I
2
solve-
here, right? If you put
Yeah.
here, yeah. But we are not checking the value of f of x here. We are just checking the limit of this. Like when x tends to 3, what will my f of x will tend to, right? So here it is 6.
Well, question here, why we limiting this thing? We can just limit it 3 because it's not defined at 3. That's why I'm limiting
No,
this.
I am taking this
expression.
example here.
Yeah.
To understand the concept.
Okay.
And here also, as we are not defined the value of this function at x equals to 3, but if you want to check what will be the value of f of x when x tends to 3 is particular, right? So I can
Okay.
simply take the limit when x tends to 3, the value will be 6. So if I put x equals to say 2.999, I will get the value of f of x as it's like 5.999 something, right?
Sir, x tends to 3 means near about every number from right side and left side tends to 3, right?
Right side and left side tends to 3. Yeah. Oh, no.
Sorry.
Say this is function, say this is like this, and this is 3 point here.
How a math can determine that x tends to what? According to this is the given for the function is given this. Why this is x tends to 3? I don't understand.
No, this my function is not defined, right? For this particular value. So I'm just taking example. So when x tends to 3, what is the function which tends to, right? At value. Yeah. So yeah, I will take one example also. Let us take.
So here in second point, LHS equal to RHS. This
Left
if
hand,
we
yeah.
in a right hand side, if we put 3.1 value, then we calculate like that.
If you put right hand side 3.1.
Basically, just 3 on number line 3, left side of the 3, we take the value 2.9, and the right side, what value we can take? 3.1 or 1?
No, it is not like that. If you put 3.1, it will be more than 6, right? So
Yes.
we are moving this towards the 2, right? Not away from the 2. We are moving this point particularly towards the 2. Okay, say for example, I'm drawing one graph. So this one. This is a graph of
1 by x.
Yeah. So my function is 1 by x here. Right? See, at this particular point at 0, my function is not defined, right? But if I say this point, at this point, this function is defined, right? At this point, so x equals to 0.00001 here. This function is defined, right?
Yes.
So if I consider this value as h, so h is very, very small than this particular limit, that is 0 here, right? So I can say here it is 0 plus h at this point.
Yes.
So my this point is 0 plus h, right? And my this point is 0 minus h.
Minus
Right.
h. Yes.
So if I take the left hand side limit, means we are going from left hand side approaching towards the 0, right? So
Yes.
for this, what I can do, so when I will get this particular 0, so when my h tends to 0, I am getting this value, right? So what I can do, my left hand side limit will be limit x tends to
0 plus
0
8.
negative. So yeah, I'm
All
writing
right.
this 1 by x, but I can write it as for left hand side limit h, sorry, here it is
0.
infinity, right? So h tends to 0. I can put this instead of x 0 minus h here, right?
Right.
So what I will get here? So 1 by minus h, that is so are you getting it what I'm trying to say? Like limit h tends to 0, which is 1 by minus h. So I can put 0. So I will get minus infinity, right?
Yes.
So as you are approaching to this 0 from the left hand side, we are getting minus infinity here.
Yeah, got it.
Yeah. So, and if you are taking the right hand side limit, so limit for this particular point, right? So at h tends to 0, my limit will be 0 plus h. I can put instead of x 0 plus h, right? The 0 plus h, that is h. So it will be my positive infinity, right? So there's plus infinity here. But are these equal?
No, these are
No.
not
So
equal.
left hand side limit, so this is LHS and this is RHS.
That
So
means
my
at
left,
0, no, limit is not
yeah.
exist.
So at 0, the function, the
Okay.
this limit does not exist. The limit x tends to 0, f of x will not exist here. It is 1 by x. Right. So in general, what I can say, so any say limit x tends to a, f of x, I can write it as limit h tend to a, f of this particular a minus h or a plus h, right? For left hand side, I can consider a minus h.
A minus
For
h,
right hand side,
a
I can
plus h.
consider a plus h.
This must be equal.
Yeah, this must be equal. Then I can say my limit will exist.
Is that x tends to a?
Sorry, h tends to a, like any value for it. Yeah. So this h is very, very small. So when this h tends to this particular value, I can reach this particular position, right?
Yes.
Sir, how this concept valid in previous example in x square minus 9 upon x minus 3, limit x tends to 3, the previous one.
This one, right?
Yes, sir.
Yeah, so at first we are simplifying that, right? So we can check whether this limit exists or not. So I'm writing this here. So limit x tends to 3, x plus 3, right? So what will the equation of line here? Like what graph?
X is equal to
Like this, right?
Yeah.
This will be 0, 3, right? So here it is 3, and here what is the value? 6, right?
yes, sir.
Yeah. So I can go from this side also and from this side also. So what I will do, I will take one small point, see here on the right hand side, such that it is distance between this 3 and this point is h. So I can consider this as 3 plus h, right?
Yes, sir.
And this point will be 3 minus h, right? So now if I want to take left hand side limit, what I have to do? Limit this h tends to 0. When my limit h tends to 0, then only we will reach the 3, right?
Yes, sir.
Yeah. Okay. So in this I have, okay. So here it should be h tends to 0, not 8. Yeah. Limit h tends to 0. So if we consider left hand side limit, so I can replace this x by this 3 minus h. So what I will get? 3 minus h plus 3. It will be 6 minus h. limit h tends to 0, I can put 0 here, so I will get 6, right?
Yes.
Similarly, right hand side, limit h tends to 0, 3 plus h plus 3. Here also I will get 6 plus h. I can put
This
h
is
equals
equal
to
to
0.
6.
Yeah, so both LHS and
R
RHS is
is
same,
equal.
right? So I can say limit exists here for this particular thing, right? So just one thing I'm telling, like if there is polynomial expression,
Just one thing. Here we can check this value on y-axis actually, like that.
sorry.
If I put the value 3, we get the output of the function is a 6 at
Yeah.
y-axis.
Hmm.
So we are checking after putting the value of 3, we are getting the 6 from left hand side or right hand side on the y-axis or not.
No. We are not putting the value of 3 here directly. We are checking the left hand side limit and right hand side limit, right?
Yes, you're right.
Yeah.
Right.
So when my x tends to this particular, I'm reaching this particular position 3. So what will be the value of my f of x? That is
F of
6
X.
basically. So if I go from left hand side or right hand side, if I'm getting the same value for f of x, it means my function like limit exists, right?
And right RHS.
Yeah.
Okay.
Sir, can I ask a question?
Yes.
Just like EX is you will work like a computer the virus production, and log X is used for compute the earthquake thing. Then what's the limit is used in what's the application of limit in our life?
That we are going to study in next lecture. If limit, continuity, differentiation, variation. If limit exists, then it is continuous and it can be differentiable. And the concept of differential is applicable in everything. Mechanical engineering also in every engineering
Differentiation I
aspect.
can. Okay.
So that thing we'll discuss in the next week. So as of now, just
Okay.
only definition is there in this week.
Okay.
Yeah. So this is particular about the limit. Now, one important thing to note down that we have discussed. So limit x tends to infinity 1 upon x. What is the value of this?
0.
0, sir.
Yeah, 0. So this is very important point because we are going to learn about the limit of sequences here, right? So what is
Yes,
limit? Yeah. So in that concept, limit of sequences, we are going to apply this case only. So what is limit of sequences here, if anyone? Same thing is there, right? So as my n stands, as I'm okay. So let's say an equals to say 3n plus 4, right? So this is any term. So what would the
Okay.
sequence of this? Like n belongs to like all natural number, right?
Natural numbers, yes.
Yeah. So if I put n equals to 1, I will get 7, right? So a1, if I put n equals to 2, I will get 10, right? So
Right.
I will get, right? So I can put
Yes.
an infinity here.
Hmm.
So what will be the value of my this particular term when n tends to infinity? That particular value is the limit of this particular sequence, right? And if that value exists, so I can say my function is converges. If that value is infinity or does not exist, so I can
Then
say
the
that
divergent.
divergent. So I will write the
Divergent.
condition here. Say suppose limit n tends to infinity an. If it is equals to some value, then I can say my function converges, right? And when
Yes.
limit n tends to
0
infinity
some value.
equals to it comes infinity or minus infinity or does not exist, then I can say
There's
it
a
is
divergent.
divergent. Yeah.
Yeah.
So in general, you can understand convergence means like this, right? Converging this particular thing, right? And divergent means like this. If we go from this side,
Okay.
this reaching this particular point, right?
Okay.
And in divergence means it does not exist, right? It is going to the infinity. Yeah.
Can you please explain the increasing or decreasing sequence also?
Increasing or decreasing sequence.
Kind of asymptote, it will not touch that 0 kind of.
Which one? Like diverges. No. It is does not have any part. It diverges to infinity, right? It is not enough simple.
Okay.
So yeah. So you understand the concept of diverges and converges, right? If limit x n tends to L, if this particular values, I can see it converges. And if limit n tends to infinity, it's giving me infinity or minus infinity or does not exist, so then I can say that this particular term is diverging, right?
So we have to simplify the function and we have to say that this converges or diverges,
Diverges.
right?
Yeah.
Okay.
So for example here, so I can say here an equals to 1 by n, right? So as
Yes.
n tends to infinity, my an will reach to 0, right? As my n tends to infinity, so I can put here like for a1 equals to 1 for 1, or a2 equals to 1 by 2, for a3 equals to 1 by 3, for
Mhm.
a100 equals to 1 by 100, right? So it is
Oh.
reaching
But
towards the
at
particular
0, it
value.
will not exist.
Yeah, at 0 it will not exist. So
Mm.
whenever we want to
Sir,
check the
I have one question. Sir, first you speak, after that anyone speak. It's better to, I think, for me or everyone. There's interrupting me. What you saying, what another one saying, I'm not correlating sometimes.
okay, yeah.
Okay, thank you. Sir.
So first I will discuss. If you have any doubt, then we can ask. Okay. Yeah. So what I want to say, if you have to find out the limit of sequence for any term, you just have to take the limit at particular value n tends to infinity, right? So for example, if f of x is this n, so 1 by n, so this my limit will tends to 0, right? So the limit of this particular sequence is 0 here, and now this function is converging, right? Because we are getting the value, right? Function converges. So any doubt in this part? No? Yes or no?
No, sir.
Okay. Okay, just understand one basic thing, like for any limit of sequences, we just need to take that particular n tends to infinity. Okay, so that's it, and that n belongs to the natural number. So that these two things are important. Okay, so okay, it's better if we can discuss few example. Uh, I, okay. I can take the activity question.
Yes.
Okay, so is my screen visible?
No, sir.
This
No,
one,
sir.
activity
Yes, sir.
question. Yeah.
Yes.
So you can consider the function a real number and natural number. So which of the which of the following represent a sequence? Yes, anyone? I just tell the two important things about whenever you are finding out the limit of sequences. You have to take the limit that particular variable at n and tends to infinity, and that n should be a natural number, right? Domain should be a natural number. So is there any function whose domain is natural number here?
F2, sir.
Sorry?
F2, F5. F2 and F5.
F2 and F5, right? So F2 and F5, for this, it will represent a particular sequence, right? Because we're taking the domain of that particular function as natural number. Now, how to calculate this? I just said, whenever we are finding out, I have to find out the limit of particular sequence, just take n tends to infinity. And whenever we are doing that limit, so we just need to consider 1 upon x, that condition, right? So if I want to make this particular expression in the form of 1 by n, how we can do that?
So divide by, sir, n by
Divided by n square.
Divide by n square. So what I will get if I divide by n square here?
3 plus 5 by n. 2 by 1.
Yeah, 3 plus 5 by n plus 2 by n square. Similarly, 6 plus 2 by n, 1 by n square, right?
Yes, sir.
Now, if
Yes,
I
sir.
put n tends to infinity,
Sir, why dividing with n square? Can you explain it?
yes, I will take. I will present. Yeah, see. So when I said we have to find out the limit of sequence, it means n tends to infinity, right? So just remember one thing, like limit x tends to infinity, 1 upon x is always equals to 0, right? So if I put direct value of n here, like it n tends to infinity, I will get indeterminate form, it is 0 by 0, right? So always we have to try to make this, but any expression in the form of 1 by a particular thing, like n. It may be n, it may be n square, anything. It should be in the denominator, 1 by n square. So for doing that, we have to take the n square common. In this case, n square is the highest degree polynomial, right? 2 is here. So we can take n square common from this side. So if I take n square common, so I will get 3 plus 5 by n plus 2n square upon 6 plus 2 by n plus 1 by n square. Right? So if I take limit n tends to infinity, so it will become, so my this term will become 0, right? And this term will become also 0. This two term will also become 0. So I will get 3 plus 0 plus 0 upon 6 plus 0 plus 0. This 0.5. So just apply this concept in the every question of limit of sequences. Okay, whenever n tends to infinity or x tends to infinity, we try to make any that particular f of x in the form of 1 by x or 1 by x or anything, right? It depends on the highest degree of that particular expression, right? So suppose if I have f of x has 3x cubed plus 5x squared plus 4x plus 2, and here 6x cubed plus 2. So what is the limit of this? The limit x tends to infinity.
Divide by x cube.
Divide by x cube, what I will get? 3 plus
5 upon
5 by
x
x plus
plus
4
4
by x
upon x.
square plus 3 by x cube, right?
Half square, 0.05.
Upon 6 plus 2 by x cube. So I will get 3 by 6, right? That's the answer. That is 0.5 only. So in general, I can say that, right? So suppose my f of x is say an x tends to n plus a n minus 1 x tends to n minus 1 plus so on. And here say bn x tends to n b n n minus 1 x tends to n minus 1 plus so on. So I have to take this x by n x to the power n common, right? From both the side, from numerator and denominator. So what I will get?
an by bn.
An by bn only.
N by Bn also.
Yeah. So an by bn. So for finding out any limit of sequences for this particular f of x like this, like it will be g of x upon say h of x. So it will be the coefficient of highest degree, right? An by bn.
Yes.
Yeah. Any doubt in this question?
No.
No, sir.
So,
Sir, 7. I have a query on 7.3.
So hence first we're discussing the limit of sequence, right?
Sir,
Okay,
one question only.
Yeah.
So sequence means we need to put the limit in front of the function, right?
Sequence means we have to, yeah. So sequence means basically at what particular value my particular term will reach when I increasing the value of that particular variable, say n here. So if I increase the value of n, what will be the my particular limit of the sequence, right? So here n tends to infinity, right? So we have to always consider that n tends to infinity. At limit of sequences, we have to find out. Just consider n tends to infinity unless we are given the particular domain. Okay, here also.
Just third number, sir.
Yes.
How can I solve it? Just like above.
Which one?
Above question. Third number, question number third.
Question number third, yeah. So here we have to find out the subsequence of the sequence of this an. So what is subsequence here? So basically it is the sequence only which obtained by deleting some of the numbers from the given sequence, right? And without changing its order. We don't have to change its order only. So I can delete even integers like 2, 4, 6. So I will get 1, 3, 5, 7. So this is just one of the subsequence here, right?
Okay.
Yeah. So here it is 2, 2, 2. This 2 here, if R2 is
Yeah.
repeating in my sequence.
No.
No. So this is not my subsequence, right? So we have to find out subsequence for this particular an, right? An equals to n. Now let us take this.
It is a sequence.
Yeah, 2 is there, 4 is there, 6 is there, 8 will be also there, right? For every 2n, the value will be there. So this is my subsequence. Now what about this?
No, sir.
Need, yes.
Which it should be in the
Yes, sir.
same order, right?
Okay. It is not in the same
Yeah,
order.
10 is not there initially. Yeah, I can say 2, 4, sorry, 2, 6, 8, 10, 12. 10 it is there, that's why it is not a sequence, right?
Not sequence.
Okay, here given is b1 equals to 10. Okay, okay. So here that is b1 equals to 10. The first value is 10, and then bn equals to twice n for all n equals greater than 2. So if I put n equals to 2 here, I am getting 4. If I put n equals to 3 here, so I am getting this sequence. But is this present in my particular parent sequence? That is an equals to n, right? No. So yeah, and here
It is
also. Yeah, it is a part of this particular sequence only. We can simply take the 3, 5, 7, 9, 11, right? So after
Right.
deleting the some numbers from this sequence, if you are getting the in particular sequence that in same order, then we can say that it is a subsequence of that particular sequence. I think 2 and this
2
is the
and
correct
2.
option. Yeah. 2 and 2.
Sir,
Now
the
what
third
about
option, can you repeat? Can you repeat the third option? 10, 4, 6, 8.
yeah.
And
So
one
see,
option two.
option 2 also. Right?
First.
No. See here, what is the definition of my subsequence? So basically, if I'm deleting some value from this particular sequence, and I should get the one sequence, right? And it should be in the same order. So here, if 2 is present, only once is present, right? So I cannot consider this as a subsequence of this particular thing. So this is not valid. It is valid, right? I will get 2, 4, 6, 8, 10 from this thing. So this 10 is present here, but not in the same order, right? 10 is present after 6, 7, 8, 9, 10. But after that, it is 11, 12, 11, 13, 12, right? Like this. So from this, I can see, okay, right, sorry, 4, 6, 8, 10, 12. This is my subsequence. But here, 10 is not a part of my subsequence, right? It should be in the same order. Yeah. So D is correct here. Yeah. As you can see, as n square is my sequence. Yes.
So can you explain the second part of the options like Bn and B1 is equals to 10 and that part?
This one, right? No, this particular sequence is given for this particular term. B1 equals to 10 here, and then Bn equals to 2n for all n greater than or equal to 2. So if I put n equals to 2 here, I will get 4. If I put n equals to 3, I will get 6, right? So this sequence is given for this particular function, right? It is b1 equals to twice in this particular term, where first value is b1 equals to 10. But according to my definition, I should get the sequence in the same order, right?
Okay,
In
so
this sequence, yeah. So
should
10 is yes, go ahead.
should we also check the second part of the options?
Second part.
Why like Bn is equals to 2n for all and
No, we just
this
need to check the sequence. Yeah,
okay.
here it is given b1 equals to 10 and bn equals to 2n, right? So if I put n equals to 5 here, I will get 10 again, right? But
Right.
that 10 is not repeating in my particular sequence, right?
Yeah, I'm just confused about the second part. Why it is mentioned in the options and we are not even checking those things. So
Okay, so are we talking about this thing, right? This part?
yeah, this part.
No, yeah. So bn equals to 2 means for this all the value of n, it will be the same sequence. For bn equals to twice n means for all value of n, it will generate, right? So if I take this function an equals to n, if I multiply by it any constant, I will get the particular subsequence, right?
Right.
It will be 3 and 5 and anything. I will get the subsequence of that. If I do the n square also, I will get the subsequence. If I do the n cube also, I will get the subsequence.
Okay.
Right?
So it is just extended part of the option. We are not supposed to watch it.
No,
Like
no. You
look
can
at.
look at this also, right? You can just think logically. We are just given the particular sequence for this function, right? Here. Both are the same thing, right? For all n, we are getting this sequence. For when bn equals to twice n, if I put n equals to 1, 2, 3, I will get this sequence. But here the first term is 10. We have defined that our first term is 10, right? And for here you can say twice n plus 1. So for all value of n, I will get, if I put n equals to 1, I will get 3, 5, 7, 9, 2, right? So this particular sequence is present in my original part, right? It's an equals to n. I can say this is also my subsequence of this particular an.
Okay, if the first part just matches the sequence which is given to us, then it will be a correct answer irrespective of the second part, right? Or
No, no, you have to see second part also. No,
can
this basically the same thing, right?
you give an example?
Yeah. So next question is there,
Like
right? Suppose if it is not given to us, right? Here it is not given. We are just given the second part here, right? You can see. Now just consider this as bn here, right?
okay,
Yeah. So consider sequence of n square. So what is the sequence of n square here? Say 1, 4, 9, right? It is square of the integer, right?
right.
Yeah. So what is consider the first case? If I add any number and I do the square, I will get the that particular value in this here only, in the sequence only, right?
Right.
Yeah. Here also, if I put n equals to 1, 2, 3, so if I do that particular square, I will get the same number in this sequence also, right? If I put n equals to 10, so it will be 21, right? It will be 21 plus square. Here also, I will get 21 plus square in this sequence.
Yeah.
Yeah. I will not get the 21 cube here, right? Because my sequence is not defined for a cube. My sequence is for n square, right?
Okay.
Yeah. So this is not correct. This is the same thing, right? And 2n squares, I'm just multiplying it by 2, right? So there are two,
Sir, why last option is not correct in this?
yeah. So let us take one example, say n equals to 2. Yes, I will get 4. If I put n equals to, so can I get 4 here? If I putting some any particular number, I have to put a rational number here, right? Then I can get n equals like a value of 4, that is 16 here. So here, and so I have say 4 here, right? In this particular sequence, will I get the 4 here? Unless I put the any rational number, the 4 I will get. Yeah, odd number I will not get, right? Just tell me.
So not getting it.
No, sir. If I put 3 here, sir, we
If I put 3
not
here,
get
I will
the
get 5 by 2, right? That is
yes, sir.
25 by 4. It is not present in my sequence, right?
9 will not get. We will
Yeah.
not get that.
So it will be only applicable when my n is even number. That is 4, 6, 8, right?
It should be applicable for all the natural numbers.
Yeah, it should be applicable for all the sequence, right? If I put n equals to 5 here or n equals to 7, will I get that particular number in my sequence?
No.
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 No, sir.
I can put n equals to 4, 6, 8. If I put n equals to 6, I will get 3 plus 1, 4, 4 plus 12. So it will be there, right, in this sequence. But what about all the odd numbers? Now, n is belong to all the integers, right?
Yeah.
Sorry, not a natural number.
Sir, the above question is a 2, 2, 2, 2, 2. There is any sequence possible like this?
2, 2, 2, 2, no.
Okay. There is no sequence possible like this.
Sir, in the third question,
Hmm.
third option. Sir,
Hmm.
if the option was like 4, 6, 8, 10,
Hmm.
and then again 10, Could that be correct option then?
That will not be a correct option.
So 10 has to appear only once at the correct place. Is it like that?
Yeah, is it there in my sequence 210? No. 10 is not repeating in a particular sequence, right? And it should be in the same order, right? The order will get break here, right? 10, 10, 11.
No, I mean to say, like, if 10 wasn't there at the first place,
Yeah, so how you define that particular function, right?
okay.
So it means you said 10 after comma 10 is there, right?
Yes,
Yeah,
sir.
so I'm increasing a particular one this term by 1 unit and I'm getting 10 again. So is it possible like, for any function for
No.
next term? Like for I am putting n equals to 2, I am getting 10. And I'm putting n equals to 3, so I am also getting 10.
Okay.
Right?
Got it.
So basically subsequence is a part of this sequence only, which we get after deleting few numbers. And it should be in the same order without changing its order.
So
That
is
is
it
So
like
for
a subset?
Yeah, if you talk about the set, then there is no order, right? You can say subset, but it should be in the same order, right? Order
Yeah,
should
we are
not change. Yeah.
also eliminating the repeating numbers.
Okay. So if any sequence is there which where I will get repeating number, yes, it can be there, but it will not be like this 1, 2, 2, 2, then 3, 3, 3, right? I will get, I can get if I don't know any function, but I can get the repeating number, but after some point, right? Not continuously, I will get 2, 2, 2, then 3, right?
Sir, for sequence type question, we always we have always a condition, or otherwise we just without condition also we can solve.
For sequence question.
Like this question number 3, question number 4. In question number 3, we have a condition like bn equal to 2, bn equal to 2, and bn equal. When in exam we can get this all we can we have a we have a like
Just function this one, right?
yeah, this type of condition we have a condition in the exam also. Without condition,
Without condition is like this one.
okay, okay,
And defining this particular condition, right?
okay.
Yeah. So for all n, right? I'm talking about. So here for all n, it will not satisfy. It will only satisfy for n belongs to an even number, right? So it is clear. Here you can see fifth question. I will get 1 minus 1, 1 minus 1 only, right? If n equals to 1, if n is odd, and n equals to minus 1, if n is even. So which of the following options are correct? Okay, now this one.
I didn't get that.
No, see, this is a particular sequence, right? If n equals to 1, like n equals to 1 if n is odd, and n equals to minus 1 if n is even. Which of the following options are correct then? The limit
Is
of
a
n is 1.
-1 to the power n sequence kind of?
Yeah, minus 1 to the power n, you can say yes, right? If n is odd, I will get no. N equals to 1 if n is odd. No, not minus 1 to the power n.
Because this is even, then we get 1.
Yeah. So if n equals to 1, I am getting 1. If n equals to 3, I am getting 1. Like this. The limit exists here.
No.
I didn't get that.
In lecture, this type of example given by the professor also.
In
If
lecture,
I
discuss
follow
that.
like
The last two options are correct.
So is this limit exist here? Like,
No, sir.
No, sir.
limit of n. Right? It
So
will not
if we
exist.
didn't know what the function is, how do you know that limit is exist or not?
Function is
We have
given
the
now.
sequence now.
A to the power n equals to 1.
No, an equals to n if n is odd, and n equals to minus n if n is even. I've given this function, right? Then okay, if I take left hand limit and right hand limit, it will exist here for this particular function. This is a piecewise function, right? It's not a continuous function.
So can you please do this thing with left hand limit and right hand limit?
No, like graph, plotting of graph here, right?
Yeah.
Discuss in the lecture only. You can see that.
Okay.
Same thing. Like here you see, if you want to find out the subsequence of that, here you can see, like I'm getting the value 1 1 1 here, right? But I am deleting this particular -1 from the sequence, right? So in the original sequence, 1 is repeating, -1 is also repeating, right? So I can get one more sequence here, that is -1 -1 -1 -1. That is Bn equals to -1 for n. That will be another subsequence, right?
Yes.
Yes, I'm talking about this particular sequence only, the initial example.
The third one is I got it. This is true.
Yeah. So limit will not exist and the subsequence will be like this, right?
Sir, for this type of question, there are two type of subsequence. Like one is positive, another one is negative.
One
Is
is
it correct?
negative. Yes, yes, right. If it is -1 -1 -1, then it will still be a subsequence, right?
Oh, got it, sir.
Another subsequence is possible here.
No.
No, if you delete -1 1, so I will get the same sequence again, right?
Sequence,
1
yes.
-1. Yeah.
Sir, explain the last point, sir. Last option, sir.
Yeah, so limit of sequence an does not exist yet. So we have to check whether left hand side limit or right hand side limit is equal or not here.
So how can we check, sir?
Yeah, you can watch the lecture. I will discuss in like once we complete this. Okay, the lecture is given. I think you can check that. So if n is odd, means what will be the condition for that particular thing? Tell me. If n is here, what will be the condition?
-1.
You can simply plot small graph. Na? Just take 1, 2, 3, 4. 1 is 1 or 2 even, just plot the graph. And take on any point, say an equals to 2, and try to find out. Right? When if I approach n equals to 2, I will get -1. If I go from the left side, what I will get? Right? You can just try to plot. Just take one few point 1, 2, 3, 4, 5. Just try to plot the graph. And see. Basically, a equals to 1 and n equals to -1 will be what? Straight line will be, right? This horizontal line will be there. Okay, we'll discuss that. I think these are based on the properties. Okay, so here, tell me which property you can apply. This particular sequence is given. Have you gone through the properties of this? Yes, anyone? No.
So
Okay. Yeah. So is this visible?
Yes, sir.
Yeah.
Yes.
So let an be a sequence of a real number where n belongs to a natural number. N is set to a limit of f if the numbers n comes closer and closer to n. So that this is a definition of particular limit of sequence, right? This conversion otherwise diagonal. Okay? This we have discussed. But there are few rules also. So when I said that particular limit of sequence for a n will tends to a, and for b n it will tends to b, then for a n plus b n also it will tends to a plus b. Okay. For c, where c is constant, For an is if tending to a, for ca is also it tends to a. So for example, I have function an. For an it is tending to 5. And for 5an also or 6an also it tends to 5. Okay. C of a, sorry, it will be tends to 6 into 5, 30, right? Now third property is of subtraction. If an minus bn, so I can say it will tends to a minus b, right? And it is the multiplicity, right? So basically, if an tends to a and bn tends to b, so I can take my function an into bn, it will tends to ab, right? So if my function is an, and if I can, it will tends to f of a. So one instead, that is 1 plus 1 by x. Okay. So here we know the limit x tends to 1 by, so limit x tends to 1 by x is 0, right? So if I say log of 1 plus 1 by x, limit x tends to infinity, I will solve this question by using this property. I can simply find out this value of a, right?
Yes.
Yeah. So 1 plus 1 by x, limit x tends to infinity. So here if I put x equals to infinity, I will get 0. That is 1 plus 0 equals to 1. So log of 1 is 0. So limit x tends to infinity for this particular function will be 0. Okay, so this is application of this particular. That f is any polynomial function. Now in logarithmic function you also work, like here you can see, right? Log of c an, log of c a, right? Same thing I am explaining here. C is basically a base of the particular logarithm. Same case you can check for f of x, like x square plus 2. Right? I can simply check the limit for this. No, wait. Yeah, it's any function, right? Polynomial function. And here, okay, an by bn equals to tends to a by b. So this is a property that we are going to apply in the next question. That is c an tends to c by a. So when an tends to a, c to the power an also tends to c to the power a. Okay. So if you see the question, here you can see, okay, so limit a 3n, n tends to infinity, right? So as my n tends to infinity, it will give the limit 1, right? So what will the value of this thing? 3.
1. 1.
So can we apply any property here? We are just simply changing the sequence n by 3n, right? Hello.
Yes,
Yes.
sir.
So it will tends to what, 1 or 0?
Sir, if an is converted into a3n, then will it not become 3?
No. If it is 3 times of an, then it will become 3, right? It is not of 3 times of an. It is not a constant, right?
Okay, it's like observation in the
Yeah.
sequence. Okay.
Sequence. Yeah. So it tends to 1 only, right? What happened?
So can
It will be
you
1, sir.
explain it, sir? Like, can you
Yeah.
solve it? Like, not explain.
Okay. Okay, say suppose I have any sequence an and limit n tends to infinity and what is given equals to 1, right?
Yes.
So yeah, that is for n. N is 1, 2, 3, 4, 5. But here I'm finding out of 3n, not of 3an, right?
Right.
Just to 3n. So what will be 3n here in this case? If I put n equals to 1, 3, 6, 9, right? So if my sequence of this particular an will tends to 1, this will also will tends to 1 only. Basically, this is subsequence of my this particular sequence, right?
So n equal to 1, we get 3. N equal to 2, we get 6. N
Yeah.
equal to 3, we get 9.
9, yeah. No, don't consider this as a function m. It converging to 1, right? If we consider like this, it will converge to infinity, right? But it is giving that an is sequence converging to limit 1. So this is given to us, right? So basically 3n is a subset of this n only. Whatever will the n, not 1 to 3, like whatever will the sequence of this particular an, the 3n will be a subset of this only, na an, like we have discussed 2 questions back.
Actually, A3n. A is a different thing. 3n is basically
No.
A3.
A3n means if I'm multiplying the particular natural number 3 in this particular sequence, so I am getting the subsequence of this. So basically, it is a subsequence of this an.
Then sir, if the sequence value is 1, then the value of subsequence is also 1, right?
It will converge to 1, not a value. It is limit.
And converges to 1.
So if I say if it is 3 times of an, then in that case it will be 3. By applying the property of limit.
An will be the 1, like that. Full value an.
For an it's tending to 1. So my C of an which tends to CA, right? This is my property. Okay. C is 3 here, right?
Right, sir.
So I will get 3 times of 1, that is 3. So these two are different things. 3 times of an and A3n is different thing, right?
Actually, here I am confusing. Like A3n, one thing I understand, okay, if I put value of n is a 1, I get 3. Value of n equal to 2, I get 6. But A, where is the A?
Where is the
A3n?
no,
A3n is a single term, or A is a different term, 3n is a different term. Right?
No. Say for here you can see this is considered this as an. Okay, this one. Now
Yes.
A3n means what will happen? I will just consider this as 3n only, right? It will be 3n. It will be 3n. So basically, I will get the subsequence of that, right? Yeah. So, okay. So how to find this? Whether it is converging or limit of this? So, okay. So we have to find out the sequence, right? So what I said, for any finding out any sequence, we should apply n tends to infinity, right? And for that, we should have 1 upon x term, right? So f of should be in the 1 by x term, right? So can I make this in 1 upon n in any by any doing any simplification or anything? Can I convert this f of an into say f of n into f of 1 by n or n square anything? Can I convert this? How to convert that?
Divide by n is.
Yeah. So this is 2 1. It is divided by 1, right?
Right.
So for 1, I can write it as this is factorization. 2 1, not factorization, rationalization. Is 2 1. I can multiply numerator and denominator by same thing, right? Under root of 2
yes.
n plus 1 here also.
Plus
2n, right? Like I can write this like this, right? I can simply cut this, I will get the same expression this one, right? Now, what is a minus b and a plus b here, right? That is, sorry, a plus b here, a square minus b square, right? So if I apply that formula here, what I will get?
2n plus 1 minus 2n.
Yeah, so an will be 2n plus 1, because under root will get, if you square it, it will go, right? So 2n plus 1 minus 2n, right? And at the denominator, I will get under root 2n plus 1 plus under root of 2n, right? So 2 and 2 and will get cancelled, right?
Yes.
So I will get 1 by root 2 plus n 1 plus root 2 n. If I put n limit n tends to infinity here, so it will be 1 by infinity only, right? That is equals to 0, right?
Yes, sir.
This whole term will be infinity only, no? So I put n equals to infinity. So as n tends to infinity, where n tends to, it will also reach to infinity. So my 1 by infinity will be 0. So this is basically limit of an is 0. Limit of an is not correct. Limit this is not correct. This a1, an is convergent or divergent? It's convergent or divergent.
So if there is no limit given, then we have to say that n tends to
Yeah, for finding out the
infinity.
limit of sequence, we consider n tends to infinity.
Okay, we have to consider that n
Yeah.
tends to infinity. Okay.
Finding out the sequence.
Oh.
If the domain is given, then we have to consider that. But sequence will be
Sir,
limit
can,
will be n tends to.
sir, can I do this like that? Multiply with n square and divide by n square.
Okay, so if you do that, what I will get? For simplification, you can do anything, right? Rationalization, right? 2n plus 1. But whether you will get anything n square into n square, what I will get?
So individual
Individual
term, like root under 2n plus 1 multiplied by n square and divided by n
Okay,
square.
okay. Multiplied by n square divided by n square. Here, no, like this.
Yes.
Yeah. But what
No,
like
no, no.
I want to bring it this in 1 by something form, right? 1 by variable form for limit x tends to infinity. How will I get from this?
No, I am not multiplying whole individual term. Suppose first term is a, another term is b.
Okay.
B. In first term, I will multiply with n square and divide by n square. And second term, same thing.
Okay. I do same thing. You know, then how will I will get to that particular thing, like 1 by something? How I will get that? Well, you can do that. You can do anything. But how I will get this form? So unless I get this form, I cannot put my limit here, right? X tends to infinity. I will get infinity always. I always try to bring in 1 by something variable, right? So that I can get I can convert that particular term to 0.
Okay.
So explain question option number 1, sir.
Huh?
Option number 1.
Option number 1 is correct, right? An is convergent, right? It's tending to 0, right?
Yes, sir. Yes.
This is also correct. Let me check. Yes.
So it should be divergent, no?
Why?
Because
No.
it is tending to 0, 0. Then
Yes. So limit.
there is no limit, no?
No. For diverging, limit, so n tends to infinity, an, if it's giving me infinity value, like an tends to infinity, then it is diverging. If the limit of sequence of this particular an is infinity, then it is diverging. Okay, it diverges to infinity. And if I'm getting any particular value, so 0 is also a value, so it is converging, right? So as I said,
Because I thought that if it is tending to 0, then at point 0 there is no limit does not exist. So
why limit does not exist?
Because at point 0, when we solved it earlier, then we were getting infinity and minus infinity, which is not equals
That
to
is
each other.
for 1 by x, not for all the function.
Okay.
Yeah,
Okay.
it's only for this function, right?
Okay, sir.
So if I'm getting the limit does not exist for infinity, So it means a function is divergent.
Okay.
Otherwise, if I'm getting any particular value, so this particular sequence is converging to 0, right? So as I increase the value of n here, I will get 0. I will converge this to 0. If you can say, like, if we just put here, what will you get? 121. Yeah, if we put 60 here, I will get 121, right? And here I will get 120. 11 minus something something. So it is very nearer to this, right? If I subtract this particular thing, I will get some 0 point something, right? If you keep increasing this value, you will reach, you will get, it will tends to 0, right? You will not reach the 0, it will tends to 0, right? That is, you are converging the function to particular value.
Okay, sir. Thank you.
Converging is like this. You are just reaching this particular point, right? Here, diverging is like this. We are going towards infinity. We cannot reach any particular point.
That means some function by calculation also we cannot make them convergent, right?
Converging. Now we have to find out the limit for that, right?
Suppose the x ln x, this what will be this function?
X.
Ln x.
X
Log means
of
log
X.
e,
Yeah.
e base x. Then what will happen with that function? Can you please tell?
Yeah. Okay. So what will happen to that? Just tell me how I can write this. Say for x equals to.
I evaluate with the infinity. I cannot solve this thing. That's why I'm asking.
I can write
Extends
this
to
as
infinity. If it
ln
extends
of
to
x by 1
infinity.
by x also, right?
If I get it to infinity, then also this is 10. This is infinity. So I can't do the solution.
Yeah, if limit x tends to infinity, right?
Yeah, right.
Yeah. So I can write this x into ln of x as ln of x by
Not
1
able to
by
see,
x.
sir.
Not able to see. Let's show you that. Yeah, so I have
Yes.
f of x as x into
ln
ln
x.
of x.
Right.
I can write it as ln of x upon 1 by x.
Okay.
Right.
Right. We can write this.
Yeah, but do we have any standard limit for this? No, right? So if I
No.
put
Ln infinity, what is the?
Yeah, x tends to infinity, what I will get?
This
So
is
0 and 0, it is not defined, right?
Yes.
Yeah, so I will not get the particular value. So in such cases, we have to apply some different method, that is
L'Hopital rule.
L'Hopital rule, yeah. So basically, you have to take the derivative of numerator and denominator and then apply the value.
Then L'Hopital rule by UV formula, right?
Yeah, so no, not
Okay.
uniform. You have to differentiate numerator and denominator individually. So ln of x will be 1 by x. And ln of 1 by x will be derivative
minus
of 1
by x
square. 1 by x square. Yeah. So if you solve this, you will get x square by x minus. So you will get minus of x, right?
Okay, then
This
is minus infinity. Then also this is.
Yeah, it is not minus infinity because you will get, right.
Okay.
So in that case, it will not be not defined. So again, you can take the derivation, but it will not consider that. Okay? This is a special case. We will discuss this in the next week, right? Okay. L'Hopital rule is there in the next week.
Okay.
Yeah, derivation is also there.
Sir, I have the same question related to this topic. Sir, yes. Sir, I have one question, sir. Can you write it down, sir? I mean,
tell me.
Sir, how to evaluate this? This question, sir. Sir, limit of x to root over 10.
Root 2.
Root over 10.
Root over 10.
Yeah. No, 10. 10 to the root 10, sir.
Okay.
Instead of 2, it is 10.
Okay, root 10. Hmm.
Root 10, and sir, in numerator, sir, root 7.
Hmm.
Under root 7 plus 2x, sir,
Hmm.
minus, yeah, bracket,
Okay.
root 5
Root 5
plus
plus
root 2,
root 2
bracket close, and denominator, sir, x square
square
minus 10.
minus 10.
Yes, sir.
Okay. Is it a graded question? No, right?
No, it is not graded question.
So if you try to put x equals to 10 here, so what you will get? Infinity, right? So here infinity, and here what you will get? Twice of 10, right?
Yes.
To put x equals to root 2, right? 2 root 10. It will reach to infinity, right?
It leads to infinity.
Yeah, if you put x equal to 10 minus 10, it will be 0, right? Here I will get particular value.
Yes.
Yeah. It tends to infinity, right? Can I simplify this? But you have taken this randomly, or you have taken question from anywhere? Yes.
Yes, sir.
I have taken this question randomly, this one function.
Yes, sir.
Randomly,
actually, I was solving this question, and suddenly I stuck with this question, sir. Because normally I used to take x to 0 or something, x to something number, but it is x to root over 10, right, sir? So I was like, how to solve this x to root over 10?
there are some different properties of that. That we are going to discuss. We have to see that, right? Okay. Okay. Anyone solve this question? Question number 8. Hello.
No, sir, not solved.
Yeah. So we are given limit an, and an equals to n to the power 1 by n has limit 1, right? So if you apply this particular property, like ln of an equals to ln of that particular property that we have discussed, right? So by that I can get limit n to the power 1 by n is 1, right? So ln of 1 is 0, right?
Okay.
Yeah. Similarly here, just take the limit of 1 plus 1 and plus n to the power 1 by n. So what I will get? So 1, so plus limit n tends to infinity, n to the power 1 by n is 1, right? We are given the sequence like this. So when n tends to infinity, it will reach to 1, right? So what I will get? And then 1 plus 1, that is 2. ln of 2. It is not correct.
Sir, is infinity to the power 0 defined?
Infinity to the power of 0 is not defined. It is indeterminate form. So we have to convert it into 0 by 0 or infinity by infinity form.
So in this case, like n to the power 1 by n, are we not getting like infinity to the power 0?
Yes, how could we?
Yeah, we are getting infinity power 0, but we are given the limit also, right? It will reach to 1, right?
Okay.
So we have to convert this into 0 by 0 form. So what we can do, we can consider this as y equals to n to the power 1 by n. Now take log on both the sides. So what you will get? So log of y equals to 1 by n into log of n, right? Now then apply the limit n tends to infinity on both the sides. Try to solve that question. Right?
Okay, sir.
Yeah. Take the log on both the sides and take n tends to infinity. So after taking a log, you will get 1 by n into log n, right? Yeah. So here tell me, like, simple, you can transfer this limit to here. So if I put just n equals to infinity here, I will get this as 0, right? This term. So ln of ln2 minus 0 will be ln2. Now here it is the limit is given, that is 1. So I can simply put ln n equals to 1 by n, that is 1. So ln of 2. So ln of 2 equals to 1. So are you getting it? Why I'm doing like this directly? We have the property for that, right? Just 1 minute. I'm using this property. What happened? I'm using this property number 8.
Property number
8, this one. So log of the base c having a n equals tends to log of c of a, where a is the limit of this particular sequence a n. Here you can see a n tends to a, right? I'm not taking the limit of this particular log. I'm just taking the limit of this a n, right? It is given to us, that is n to the power 1 by n is 1, right? So I'm simply transferring this limit to this. I'm using this property here. So this properties are simple, but try to memorize this property. Okay, last 3 properties. Now in the 4th option also, yeah, here you can see I have if c to the power a n, I can write it as c to the power a, right? So what it will get me? Same thing, right? Hello. Are you getting it, or I'm confusing you? I'm just applying the properties. Nothing else.
Getting it.
Yeah, I'm just applying the those properties. That's it. So if I get 1 here, so 4 minus 1 will be 3, right? So which will be my option. Yeah.
So can you
Any
solve,
other doubt in this?
can you solve it, sir? Yes.
Question number 9.
Option number 4, sir.
Question 4. Yeah,
Question number 8, option number 4, sir.
question number 8, option number 4.
इसको solve कर.
Yeah, so I'm simply multiplying this particular 1 by n by 3, right? So if you observe, where is that property? Now this screen is visible, right? Total.
The screen is visible.
Yeah.
Yes, sir.
Yes, sir, visible.
Yeah, so I'm just taking the limit of this particular thing. Like I can take 4 as a constant and limit n tends to infinity n to the power 3 by n, right? But we have already given this a particular limit as 1, right? So if I put 4 is as a 1, so 4 into 1 will be 4, 4 minus 1 will be 3, right?
Yes, sir.
So we are given this, we have defined this sequence, right? It has limit 1 here. That's simply applying the properties and just finding out the value. While solving the question, I will suggest you to keep the properties open and check which other properties we can apply to this particular question, right?
Okay, sir.
Yeah, this is shared to you, right? These properties are shared with you. You can check resources from instructor, it is there. Okay, so in question 9, if a n and b n be 2 sequence such that and okay, and where n belongs to natural number and limit n constant to b n equals to 0, and find out the limit of a n. Okay, tell me how to do that. Yes, anyone, which thing I can apply? 11. Yes, anyone? Okay. I will take this question. Yeah, so let A and B and the two sequences such that A n is not of n is less than or equals to B n for m greater than equals to m. So where m belongs to my natural number, the limit n tends to B n equals to infinity, right? So equals to 0. So I have one sandwich property here. Like the lecture you must have seen, right? So what are these properties? So Cn tends to A, and is writing it down from that property only. Or any other. If An belong to Cn, belong to Bn. If Bn is tending to A also, the limit of this particular sequence Bn is tending to A, and limit of this particular sequence is also tending to A. I can write this that this Cn is also tending to A, right?
Yes, sir.
Yeah. So can I apply this property here?
Yes, sir. Yes, sir.
How? Can you?
It's a Bn limit n tends to Bn equal to 0. So yes,
Yeah. So this side is equals to 0.
Bn
Right.
also 0.
Now here n is greater than equal to m, right?
Yeah.
So m belongs to natural number. So till m, okay, where m is greater than, where m belongs to all the natural number. Yeah, it is greater than natural number. And limit is greater than. We find out the value of m. So this is given to me. So I can write it as bn greater than m. So that m belongs to infinity. So how I can use this property? Yes. Yes, and see here. So my Bn is given to me, that is Bn is equals to, my Bn is tending to 0, right? So for this condition, can I say that this An is less than or equal to Bn, right? An is less than or equal to Bn. But what is the left hand side, right? It is a sandwich property, right?
Cn tends to
Yeah, Cn tends to A, because my Bn is tending to 0, right? So my An also tends to 0 if you apply this property. Right?
yes.
Please go through the properties. By solving any question, you should remember those things. At least last three, 4 properties we should remember. Right? Okay. Any other doubt in
Yes, sir. Question number 11, sir, also from this activity.
7.4?
Yes, sir. Yes, sir.
Okay. Increasing or decreasing sequence means what?
Yes, sir. How are we going to approach, sir, to find the increasing and decreasing sequence?
Just check, take limit n tends to infinity. If we take limit n tends to infinity for this particular function, that is first option,
Yes, sir.
3n minus 5, 4n plus 2, right?
Yes, sir.
Now tell me what I will get here. I have to take n common, right?
Yes, sir. One by one.
So 3 by 4 I will get, right?
Yes,
This
sir.
0.7. Is it decreasing sequence or increasing sequence? So my function is converging, right?
Yes, sir.
The function is converging and then decreasing, right?
Okay. Okay, sir. I get it.
So does it have any relation with slopes? Like if we find the uh, slope of
No,
the
no.
given
Slope
function?
for we find out whether the function is increasing or decreasing, right? This for the
Yes.
sequence, not for the function, right? We're finding out the sequence here.
Okay, so if it's converging, then we say it's a decreasing sequence, and if it's diverging, it would be increasing.
Yes.
Okay.
Is that true? So what is the sequence? If I put n equals to 0, right?
Which option, sir?
No, no. Here, second option, if I put n equals to 1, I will get. You can put also like look like this. Like if you put n equals to 1, what you will get? That is minus 2 upon 6, right? You will get minus 1 by 3. If you put n equals to 2, you will get 1 upon right, 2, 8, 10, 1 by 10, right? This okay, so I'm getting 1 by 3, and I'm getting 1 by 10 for n equals to 2. For n equals to 3, I'm getting 9 minus 5, that is 4. For 12 plus 2, it is 14, right? So this is 0.1, this is 0.3, and this is increasing, right?
So for which question, sir?
This is only by sequence, right?
Oh.
This sequence is my increasing, right?
Yes, sir.
It will converge to 0.5. Sequence is not my decreasing, right? That's it.
So in divergence of point, so limit in divergence, when we finding the divergence, sir, then we check for the infinity, sir.
Yeah, diverging or converging, we need to check limit n tends to infinity. If it's giving infinity or infinity, it is diverging. If it's in particular value, that is converging, right?
Okay, sir.
But here, decreasing sequence means what? That is the terminology. Because if I'm putting n equals to 1, 2, 3, I can see my sequence is increasing, right? Initially, it was negative, then 0.1, and it is greater than this, right?
Yes, sir.
So it will reach till 0.75. That is 3 by 4. So my as the number n will increase 1, 2, 3, 4, my sequence will also increase here, right?
Yes, sir. Yes.
So this is not a correct option, I think. Yeah. So here that decreasing or increasing does not relate to converging parameters. Yeah. Sorry for that. Just verifying that. Now you can check for the second option.
So, sir, how we can conclude the earlier option? It is decreasing, not.
Just put n equals to like 1, 2, 3, and see what the increasing our sequence is increasing.
Second option is increasing.
If I put n equals to, here you can see minus sign.
Minus.
So if I put n
Decreasing.
equals to 1, it is 1. If I put n equals to, it is minus 1, right? If I put n equals to 2, that is 16. Oh, sorry, 7. Right. So this minus 1, and I'm getting less than minus 1, right? If I put increasing 3 here, 18 minus 5, that will be 30, right? So minus 1 by 30. So we are increasing sequence, right? We are going toward this side from minus 1 to say point something, right? Point, it is 1.4 something, right? Here I am getting minus of, so where we do, so our sequence is increasing, right? So minus 0.14 is greater than minus 1, right?
Yes, sir.
Yeah, so this is increasing sequence, right?
So in this type of question, we put n numbers, sir. N equal to 1, 2, 3, 4, etc. Sir.
Yeah.
Okay.
Sir, how first option is decreasing, sir? It should be increasing, right?
Right, it should be increasing because as we put the value of n, it is increasing. So it is tending towards 0.75, right? Yeah. So it is increasing sequence. Minus 1 by 3, 1 by 10, 4 by 14. Just
You
put the
said
value
like,
n equals to 1, 2, 3 and try to see whether our pattern is following, like either it's increasing or decreasing. Here also, like if I put n equals to 1, what I will get? 2 minus 1, 2 minus 1. Then if I increase, no, right?
no, sir, it should be decreasing, sir.
It is always increasing, right?
This is
n
also.
yeah. So if I put n equals to, no, it will be also decreasing, right? Yeah, it is decreasing. So my B and C will be correct. Okay. Okay, any problem? I think there are few questions in practice and also based on the limit of sequence. Anyone tried the practice assignment question based on this concept, limit of sequence?
Abhini, sir.
Huh?
Not yet, sir.
Okay. Okay, any other activity question?
Yes, sir. Activity, sir, 5. Question number 3rd, option, sir. Second last option, sir.
5, right?
Yes, sir, same doubt, sir. Activity 7.5.
Question number?
Question number 3, third.
Question number 3, okay. This one, right? Is it visible? Question?
No, sir.
Just this whiteboard.
Yes, sir. Now visible, sir.
Okay. Which of the following options are true? So first check limit x tends to 2, f of x minus 1 or not. It's possible because for all the value x greater than 0, it is equals to 1, right? So this is not correct. You can plot the graph also for this. X is greater than or equal to 0, it is equals to 1. Like this. X is less than 0, it is equals to minus 1. So this is 1 and this is minus 1, right? Like this.
Last two options, sir.
Last two options. Yeah. So limit x tends to 0, f of x is equals to 1. Is it correct? But my left hand limit and right hand limit will exist or not? I have to check from both the sides now for limit x tends to 0.
Yes, sir.
Yeah, so it will not exist. So this option, right? Last two options.
Yes, sir. Yes.
Right limit at x equals to 0, that is x plus, does not exist. Yeah. So right limit from this side, right? X equals to plus. What will the limit for this? Limit will exist, right? Because it is equals to 1.
Yes, sir.
Yeah, so this option is wrong.
Right limit.
It is given right in the portal. Does this limit exist or not? This one. Right limit at x equals to 0.
Sir, right limit at 0 is not 1, sir?
It is equals to 1, right?
Yes, sir.
Now if you approach this from this right hand side, because it is you can say that equal to or greater than. So it will include, right? It is point, and this will, it will not include, right? So if we go from the left hand side, we will not get equals to 1.
It's
So
a
we get
minus one,
minus 1.
sir.
Yeah.
Yes,
The
sir.
limit
So
will
does
not
not-
exist. Like left hand limit is not.
Yes, sir, I get this point, sir.
But this limit will exist, right? Right.
Yes.
Both the limit will exist, but it is not equal.
Yes, sir. And the last option, sir. Limit of the function at 0 does not exist.
Last option.
Yes, sir.
Okay. Limit of function at 0 does not exist. Yeah, you can see here it is giving 1 and minus 1, right? So if I tens from this left hand side, what I will get? 0, negative. From this side, I will get minus 1, right? If I go from this side,
Plus.
limit x tends to 0 plus, I will get plus 1. So limit does not exist, right?
Okay. Let's see.
Let me check the option.
So question number 9th option first, sir. How minus 1 is minus 8 is answer? Not.
Sorry.
So question 9, sir. Option first.
Which activity?
Same, sir.
Same 7.5.
Yes, sir. Yes, sir. Minus 1.
This one, right?
Yes, sir. Option first only, sir.
Yes. Try to factorize it. Tell me your approach. How did you do that?
So first we require to factorize, then putting the minus 1 value, no?
Yeah, even if you put minus 1, what you will get here?
So 0 by 2.
Sorry, you will get 0 by 0, no?
No, sir.
1 minus 3. If you put x equal to minus 1,
0
it
by
will be
0.
1 plus 6 minus 7.
7.
Here also 1 minus 3 plus
minus
3. 0 by 0.
equal to
no?
0. Yes, sir. Then
So either you can do factorization.
I get, sir. I get, sir.
Or you can do L hospital rule, right?
Yes, sir. Yes, sir. I get, sir.
So as you can see, like x minus 6. Same thing apply can for all the options, right?
Yes, sir. Yes, sir.
Okay, any other doubt in activity or practice?
Sir, I have few doubts in practice assignment.
Question number?
Question number 1.
Question number 1. Yes, tell me.
Yes, sir. Sir, the option number 4 in this, which says
Unique
there is a
tangent, right?
unique tangent at the point x is equal to pi, but not at x is equal to minus pi.
No.
So I feel if we pass the tangent through minus pi and pi, so are we not getting a common tangent in between them?
Yes, it is a common tangent, right? If you pass the, because we are getting the same value here, right? If you pass the tangent at this particular point, we get a common tangent only. It is a unique tangent for both the cases, right?
Right. So they're asking.
So I think this should be correct. There is a unique tangent at x equal to as well as x equal to minus 5.
I'm asking in that way, like minus pi has a separate tangent and pi has a separate kind of tangent, because in this case they're sharing a common tangent, which is the probably the x-axis.
No, at this point you're talking about no. Pi and
minus
pi. Okay, okay. So this is pi and minus pi. Yeah. This is a common point, right? Common tangent only, no? This one.
Right. So how can we say it is unique?
So it is touching at this particular point only, right? One
Right.
point only. And here also single point only. So is there can we draw a different tangent here at this particular
No.
point?
No.
No, right? So just unique and common tangent to both the cases, like you need to minus pi and pi.
So it's not like this minus pi should have a different tangent and pi should have a different tangent at
We're
different
talking about
inclination.
this particular point now.
Right.
Yeah.
So
should have
at
the
this
same time.
point, they're
Yeah.
talking about whether they have a tangent or not, and if it's unique. It
Yeah, it
doesn't
is
matter if
unique.
it passes through both.
Passes to me, it is tangent to the both the points, right?
Right.
Yeah.
Okay. And so question, yeah.
Yes. In this.
Question number 3.
Yeah, 3 only.
I didn't understand how to approach it.
Okay. Same thing you have to apply. We have to find out the sequence, right? So just take n tends to infinity here. What is the value of an here? If I take n tends to infinity for this.
If we divide by both n in this case,
I will get
it would
39
be
by
1.
39. 1, right? Now just define the function. Just put an equals to 1 here.
Okay.
So you will get, because if you put an equals to n, sorry, the limit of sequence dn defined by dn. Yeah. So just put, take the limit here, like n tends to infinity, because you have to find out the limit of this particular sequence also, right? So by this property, I can take this constant outside and I can apply the limit for this particular function only, right?
So 1 square is 1. So
1, yeah, because limit of this an is 1, right?
Right.
So if I take limit of a square n, it will be 1 ka square, that is 1.
Okay.
So here it will be 1520 into 1. Now here if you apply limit of n tends to infinity, what we have to do here? We have to take the...
Sir, again, if we substitute 1 here.
No, we are not substituting 1 here. If n tends to infinity, we have to find out the limit of...
Okay. Yeah, so it would become 39.
No.
Like if we divide by
n cube.
We don't have to put the value of n.
Okay.
Just 1 minute. I didn't read the whole. Here you can see we have to find out the limit of this particular thing, right? Limit of sequences bn. Right. So limit of sequences bn means n tends to infinity and bn, right?
Yes,
so my
sir.
bn is limit n tends to infinity. This particular 59319 a square n plus 1521 an plus 3939 square plus n cube plus 1. So I can transfer this limit to all the terms, right? To this term also.
Yes, sir.
Yeah. So, but for that, I have to do, like, I can take the constant outside. Property 59319 limit n tends to infinity a square. You have to calculate the value of this limit. So from where should I calculate? Like similarly, I can write down here to 1 limit n tends to infinity an plus 39 outside limit n tends to infinity n square by n cube plus 1. Now first we have to find out this particular value of this limit. So how we can find out? We have to find out the limit for this an, limit of sequence an, that is equals to 1, right?
Yes, sir.
Limit, yeah. But by applying the property of this, like if an tends to a, so I can simply write the limit of x n tends to infinity as a square n tends to as a square by property. So if I
Yes, sir.
substitute here, so that will be 5913 into 1 ka square plus 1521 into 1. But here we have to apply the limit again, right? This limit we have to solve.
So if we divide by n cube in
N
both
cube.
numerator and denominator, I think that should do.
Yeah. So if I divide it by n cube, what I will get? 1 by n here.
Yeah.
And here 1 plus 1 by n cube.
Eventually, the whole expression becomes 0, I believe.
Yeah. No. So not whole expression. If you see, if I put n equals to infinity, I will get 0, right? Here.
Yeah.
That is 1 here. And if I put n equals to infinity, that is 0. So that's basically 0 upon 1, that is 0 only, right?
Yes.
So I can just add these two terms, I will get the answer.
Okay.
Yeah.
Yes.
Any other question?
So
Yes,
Sir,
sir.
activity,
One last
activity 2,
question.
question number 7.
Okay. Any question practice assignment first?
Yes, sir.
Anyone?
Question number 4.
Question number
4.
4 only, right? 3 steps. That's right. Yeah.
Sir, in this I didn't understand like how the statements were correct actually.
No,
Like
no, it is
third
from the
statement.
all the properties only. Like if an tends to a, bn tends to a, then an will be also converges to some non-real number. It is ab, right?
Yes.
Same for this one. Here also the constant sequence is equals to c for all real numbers c. For I, it always converges because it's a constant number, right? It will always
Yeah, so
have
all the
particular
limits
c.
go to C. But I was confused in statement number 2 when they said A and Bn may converge
Converge.
even if neither An nor Bn converge. So how is that working?
Yeah. So if we take two terms like those who are not converging, say any term, say -1 by a to the power n, or say 2 minus 2 to the power n, and if we find out the limit, then a and bn will not be converted, may not converge. Just take two functions an and bn, might try such that those are diverging, it is not converging, and just find out whether this multiple product is converging or not.
Okay, sir. But it should like converge eventually.
Yeah, it will converge. Yeah, because we are taking the product of it, right?
Okay.
Anyone? Any other question in
activity
practice?
2,
Activity 7.2. Question number
10, sir.
10. This 8, 9, 10 all belong to the same thing, right?
Sorry,
Yeah.
just last, sir. Last 11. Last.
This one, option
Yes. No, sir. Last, sir. Last 11th number.
11 number. Okay. Once 8, 9, 10, there is one shortcut. This is a particular formula for all the trigonometric. There is one shortcut also that I will tell after this. But first we'll solve the question number 10.
So in this question, we put the value fx on the value of x, same like this.
Yeah. Instead of x, we'll put the value of f of x, and we solve for it. Say it's composite function, right?
Yes, sir.
Yeah. So our f of x is this x plus a. Now if f of x is like this, right? So
Yes,
if I
sir.
put instead of x as f of x, so what I will get? It will be instead of x, I will have to put this full term, right? That is f of x.
Yes, sir.
F of x upon f of x plus a. So I will get x plus 3x plus 4 upon x upon 3x plus 4 plus 4. Right?
Yes, sir.
And solve it. I will get x upon x plus 12x plus 16. Right? No. 12x plus 16. Right? X upon plus 12x plus 16. Right?
Yes,
This
sir.
will get cancelled, right? 3x
Yes, sir.
plus
Yes.
4, 3x plus 4. Now what we have to do? We have to find out the value of a. Okay. Where is a? Okay. So that's what I have done. Okay. Sorry.
We put the value
So
of
here we have to
x.
put the value of,
Yes, sir.
instead of this we have to put like f of x is this is not this, right?
Yes, sir. Yes,
So
sir.
x upon x plus a upon x plus x upon x plus a plus 4. Then we have to equate to
This
this.
is 3x also.
Just say plus 4. So I will get this as x upon.
So whole
There
3,
will be
sir.
3, sir.
3,
3
sir.
into
3.
x by x plus a.
Okay.
Down.
Three.
Yeah.
This one is 3.
Yeah.
So I will get 3x plus 4x plus 4a. Right? If I multiply this, then it will get cancelled. Now this is equals to my this, right? 3x plus 4.
Okay.
Is it correct? X plus x by a plus 3 into x plus x by a. So
Yes,
3x x plus 4 plus 4, okay, right? So this is cancel out. 3x. Something is
7x.
missing. This is not 4 now. This is a. So 3x plus ax, it is a square now. Why I am taking this square. Right? We have f of x is x plus a, and then we have to take in the function of this composite function. So we have to again put f of x plus a, right? This is a, not 4. This is a. So it will be 3x plus ax plus a square. Now, yeah. So x's will get cancelled. So it will be 3x plus 4 equals to 3x plus ax plus a square. So I can write it as 3 plus a into x plus a square. Now here 3x plus 4, right? Now I can equate the coefficient here of having the same degree. I can equate the coefficient of x here. So 3 plus a equals to what is? The calculation mistake is something, and 3x plus 4, right? It is not 3 now. Let me solve this question. Okay.
Yes, 3 should be not there.
Yeah, it is not 3. Someone said 3, that's why I took that 3. Okay, so up till now you got this, right? f of x is like this, right? Now I will put x upon x plus a upon x plus a plus a. Okay, now what I will get x. I will just cross multiply here x plus a, sorry, x plus ax plus a square, right? Now this is equals to my x upon 3x plus 4. Now this x will get cancelled, right? So I can write it as 3x plus 4 equals to x plus a, ax plus a square. Now this is 3x
X
plus 4,
common.
x common a plus 1 equals to a square. You can convert, you can compare the coefficient of
term.
having the same, having same degree, right? That is a plus 1 equals to 3 or a square equals to 2. That is a equals to 2 here, right?
Yes, sir.
Yeah. So here a equals to plus minus 2, but here it is satisfied a equals to 2 only, right? So answer will be a equals to 2. Yeah. Okay. Who asked this question? You got this, right? Hello.
Yes, sir.
Yeah. Okay. Any other question?
Question number 7, sir.
Which
Same
which
activity.
Same
activity.
This one.
Yes, sir.
Okay.
No, yeah. How to approach this question, sir?
Okay.
Sure.
So how to find out the domain of composite function? Like this g of x, right? In all the cases, we have to find out whether this g of x is well defined or not, right? G of x means g of f of x, right? So how to find out? Well defined means what? Like yeah. So we are getting the we are getting this range for if the subset of these is okay. Tell me the first step. Like what are the steps involved in how to find out the domain for this composite function? Anyone?
So the domain of Gx should be the subset of the range of f.
Yeah. So we have to calculate graph here, right? So first we have to find out the domain of this f, right?
F.
First we have to find out the domain of this f. Then we have to find out the range of this particular f.
Okay.
Right? Because this range will be the input for this particular g, right? Then we have to find out the domain of this particular g.
Okay.
And now there are two cases. Say case one. If range of g means range of g, say range of g is subset of domain of f, right? Then I can say this,
The screen not visible, sir.
which one?
The math you are doing is not visible. That's why I'm asking.
So what I'm writing is not visible. Like,
No, I think you was explaining something. That's why I'm asking. You are not writing anything, right?
yeah.
Okay.
So,
Sorry.
yeah. So here there are two cases, right? Case one is this is for well defined. If my this range of this particular f is this
And you are
range of
writing,
this.
screen is not visible where you are writing actually.
Oh, okay. I will show it. Now visible. I have written this case one. Hello.
Yes, sir. Now
Yeah,
visible.
now visible.
Okay. So case one is for well defined. So when I can say this is well defined, when this my range of this particular function f is a subset of this domain of g, means range of this particular f is my subset of domain of g, then I can say that this composite function is well defined. Right?
Yes.
Then I
Right,
can
sir.
say that the domain of this graph, say graph of x equals to h of x, and is equal to domain of g of x, that is f of x here. Domain of g of x, okay, this h of x. So when will my composite function is well defined for this particular condition. And in case two, what will the case two? The composite for this, right? And range of f is not a subset of this domain of g, right? So in that case, what we'll do? For finding out this domain of this particular composite function, we usually eliminate this particular value which is not satisfying this particular condition, right? Okay, have you know about this thing, like this condition? Have you learned this thing, like
Yes,
case one,
yes,
case
sir.
two? Yes,
Yeah,
right?
yes, sir.
So for
Got it.
well defined, it is we have to satisfy this condition. Now check for first option. What is the domain of f here for first option? Tell me.
Real number.
Real
R.
number. R.
R.
Range of f.
R.
R, sir.
So it is a codomain, right?
Yeah,
Yes, sir.
codon.
It will be range will be subset of this particular R.
R. Yes.
Yeah. Range of the subset of particular R. Now what is the domain of G here? Just for first function only. Q. Right? So what is Q here? Yes, anyone? What is Q? What is R?
R, sir.
No, what is R? R is a R stand for all the real number.
The real
Yes,
number.
sir.
Q stand for
Irrational.
Irrational.
Rational number.
huh?
Rational number.
Natural number.
Rational.
Rational, sir.
Rational.
Rational
Rational.
number. Yeah. N stand for
Natural.
Natural.
yeah.
Natural numbers.
Yeah. So yeah, we have Q, R, and Z stand for
Integers.
Integer.
yeah. So now see, this Q is rational number, right? Now this condition is satisfying this range of f, that is subset of R, is my rational number. Can you see? It is satisfied. What is RF?
No, I think.
This for option one. See, the range of f is subset of R, and this domain is Q, right?
Yes, sir.
Now, is it true? Can it be a subset of this particular rational number? This belong to a real number, right?
No, sir. No,
No,
sir.
sir.
This cannot be possible. So my
Yes.
first option is not correct.
Yes.
Now go for option two. Now go for option two. For here, my domain of so option two. So domain of f will be.
Sir, I will solve after that. I understood.
Sorry.
No problem. After that, I will solve it.
Yeah. So domain of f will be n, right? That is
Yes.
natural number. The range of f will be
Z.
z, right? And the domain of g will be here
Q.
q, right? Now check this condition. Z is a subset of q. What is q here? Rational number. And z is
Rational
my
number.
integer.
Integer. Not
Yes, it is possible, right?
Yes, sir. There is a
So this
possibility.
condition is satisfied.
Yes,
So
possible.
this is correct. Now check for option 3. For option 3, domain of f is 0, r, right?
R.
Range is 0, 1. Right? It can be subset of this also, a subset of this particular thing.
So we read the 0 to 1 or 0, 0, 1 only.
Between 0 and 1. This is open bracket, right?
Okay, sir.
So, and what is the domain of G? 0, 0, 1, right? Now check this condition. The subset of this.
Yes, sir.
It's equal.
Not equal.
Yes, sir. Yes,
We
sir.
have closed that, right?
Yes, sir. Yes.
This is true, right?
Yes.
So this is also my well-defined function. Now what about the third option?
It's just opposite, sir. Wrong, sir.
Yeah, so this is real number, not real number. This is integer. Then it is 0, 1. It will include 0 and 1 also, right? It is 0, 1. So this is not possible. It should not be it cannot be a subset of this because 0 and 1 is not included here, right?
Yes, sir.
Yeah, so this is not correct. So option B and C is correct here. But in the case, if I mention here fog, in that case, you have to check all the option again, right? It will be different options, different, right? If I just change golf to fog, right? We have to check the domain of G first, then range of
Then
G
F.
first, then yeah, it will be different. Okay. Any other question? An activity or practice?
Activity 3,
The
question
same
number
as-
169.
Yeah, just 1 minute. Activity 7.3. Question.
1.
Question 1.
Yes, sir. First number.
Okay. Just tell me.
Just tell me the last two options, sir. How can I graph of F subset
So
of Z R.
F is defined from R to R, right?
Yes.
Now the subset of that will be R to R only, no?
R2.
The graph, yeah. Z is the integer. Right? Z is not, yeah. Okay. Any other doubt in activity or practice?
Then activity to question number 6.
Activity 2, question number 6. Okay, this is bound function, unbound function, right? Yeah, sin x is a bounded function or not? If I draw the
It is
graph
not
of
bounded.
this,
It is not bounded. Unbounded. Sir, I have talked into option number 4.
so wait, my screen is visible, right? Portal. Now it's visible, right?
Yes, sir.
Yeah. So yeah, so graph of sin x is like this. Graph of sin x is bounded, right?
Yes.
Yes, sir. 1 to 1.
Cos x is unbounded. That is not true. Cos x is also bounded, right?
Yes, sir.
Graph of sin x is bounded. Graph of cos x is bounded.
Sir,
Graph
in
of tan
says
x.
bounded
Tan
function
x
and
is
periodic
unbounded.
function is same.
Sorry?
Says bounded function and periodic function is same.
No, bounded functions, periodic functions are different. Wait, let me take this question. You are asking a periodic question, no? A periodic function, no?
Yes.
Yeah. See, what is the graph of sin x here? If I draw this like this, it will be this side also. It will be like this. Right? 0, pi by 2, pi, 3 pi by 2, this 2 pi. Right? Now this function is bounded between 1 to minus 1. This function is bounded, right, between 1 to minus 1. So the lower bound of this function will be minus 1 and upper one will be 1, right? Now periodic means this graph is repeating itself after equal interval of time. So the periodic function for sin x is 2 pi, right? Same graph
Pi
is
0 to
repeated.
2 pi.
Yeah, 0 to 2 pi, right? So same graph will repeat itself after 2 pi, right? Again, we can see the same thing is there, right? It is 4 pi. Same thing you can find out. That
Sir, not able to hear you.
I also.
hello, am I audible now? Hello.
Yes, sir. Yes.
Yes, sir. Now you're
Sorry,
audible.
my Wi-Fi went off. Just one minute. So sin x is a bounded function, right? Similarly for cos x also, right?
Yes, sir.
Yeah, cos x graph will look like this. It will start from here.
Pi
Like
by
this.
2, 3 pi by 2.
Yeah. So it is also bounded. Now what about
Yes.
tan x?
This is bounded between the even function.
Yeah, like this, right? So it don't have any upper limit or lower limit.
It is not bounded.
Yeah.
Unbounded.
Unbounded. So this one is correct, this one is not correct, this one is unbounded. And what about this?
Okay.
1 upon 2 plus cos x. So cos upper bound is minus 1 to 1, right? So if I put a minus 1 here, what I will get? 1. If I put a plus 1 here, what I will get? 1 by 3. So this function is bounded from 1 by 3 to 1, right? Hello.
We have to found the boundary by this
Yeah,
by
this
this.
function is bounded, so this statement is not correct, right?
Okay.
Understood.
Yeah. So this function
Got
is
it.
bounded between 1 by 3 to 1. So number of statement will be 2, right? Correct. I think. Yeah, this one is also correct. So 2 statements are correct.
3 should be.
Yeah. 3 statements are correct. No, this is not correct, and this is also not correct, right? Only 2.
Only 2, sir.
Yeah.
2 should be the answer.
Okay. Any other question? Activity
Sir,
from
7.3.
7.3. Okay.
Question number 9. Sir, I'm not able to understand this thing.
Cardinality means number of values it can take, right? So if A and B, if a function is defined from A to B, where A and B is a finite subset of R, then which of the following functions are correct? So basically A is domain and B is codomain, right? Yeah. So cardinality of F will be the same as cardinality of A only. How many numbers are there? It can take domain. Yeah. And cardinality of F is less than or equal to the cardinality of A into B across B.
Okay. Okay.
Yes. Okay. Any other doubt?
Sir, activity first, sir. Question 10, last option, sir.
The question you have solved in the last slide, like cos x is bounded, right? It is not unbounded.
Cos x is bounded. Yes. So that is wrong statement, right?
Sorry.
Yes, cos x is bounded, right, between minus 1 to 1.
Yeah.
So that is a wrong statement. Na? Here you can see. We have to find out which of the following statements are correct.
Okay, okay, okay.
Like, what is your doubt? Like,
No, I thought that it is bounded and we are okay. My bad.
okay.
Yeah.
Yeah. So last statement, right? Question
Yes,
number
sir.
10.
Yes, sir.
So when I can say function is bijection,
Yes, sir. For on to on, sir.
when
to,
it is 1 to 1 and on to both.
Yes, sir.
Yeah. So just check whether it is 1 to 1 or 1 to. If it is one both the function, that is a bijection, right?
So for on to what we can, how we can solve, sir?
Like, what is on to like? Tell me, like for every value of y, like for every value of see if its function is f belongs to say r to r, say okay. So from D to codomain, right? So for every value present in the codomain, there exists like it exists a mirror image in the particular domain, right? So that is on to one, on to.
Yes, yes, sir.
It is discussed in the.
Yes, sir. I get it. Now next.
Okay. Okay. Any other doubt? Yeah. So one thing like what I want to discuss. Yeah, I think this one, right? So these are the formulas, right? Trigonometric formulas. So like it is very useful when you are doing any simplifying any trigonometric function, right? So
Yes.
just 1 minute. No need to remember those things. Just 1 minute. Okay. So what are the basic trigonometric function we have? That is sine, cos, and tan,
tan.
right?
Yes.
Yeah, tan of x. Okay. So if I draw this x-axis, not x, say anything like x or y. So here, this is my if I'm taking this as degree, right? So it will be 0, it will be pi by 2, it will be pi, and it will be my 2 pi, right? 2 pi, not 2 pi, sorry.
2 pi by 3.
3, yeah.
3 pi by 2, sorry.
3 pi by 2, yeah. So now, see, remember always one thing, like when we are adding or subtracting from pi by 2, it will change the function from sine to cos and cos to sine, right? And if you're adding or subtracting from pi, the function will be same, right? Sine. Okay. If it is adding subtracting from pi by 2, it will change to cos. And if it is pi, the function will remain the same, whether it's sine or cos. Now, whether it is positive or negative, how to determine that? So if the function lies in the first quadrant, so like here, all the trigonometric functions are positive in here. Okay. Here only sine functions are positive. Here only tan function is positive. And here only cos function is positive. Yeah. So when I say sine pi by 2 minus theta equals to cos of theta, right? So how to remember this thing? There's simply one thing like here A stand for all the trigonometric function, S stand for sine, T stand for tan, and C stand for cos. So just one thing like add sugar to coffee, right? If you add sugar to coffee,
Wow, sir.
yeah.
Nice.
So here you can see all the trigonometric function are positive in this particular quadrant. Here only sine function is positive. Sine function is positive means 1 upon cosec is also positive, right? Now tan function is positive means when it is tan function is positive, my both sine and cos will be negative, right? So both sine and cos will be negative in this thing, but this ratio will be positive. This tan function is positive, and here my cos function is positive. So just simple trick, you can apply this trick in solving the 3 questions. Okay.
Okay, sir.
Okay. Any other doubt?
No, sir. Done.
Okay.
Sir, there is a
Hmm.
video, summary video, open session, some video in the lecture. There is a, 1 second. I will tell, I just open the page. Yeah.
Re-
There is a question, let AN be a sequence and defined by AN is equal to n to the power 1 by n. Has limit 1. Okay. Then there are some options, and then she n equal n by 1 by n, she just derived like e to the power ln 1 by n. I didn't get that explanation.
Which video? Tutorial.
Uh, Except 1 second, I will tell you which video is this. This is the video of Solve with Us.
On with us. Solve with us basically practice assignment, you know. Which question number?
1 second. B something. I didn't know the question.
Wait, I am sharing my screen. Solve with us, right?
Yeah, Solve with Us.
Which one?
A to the power is equal to n by 1 by n. N of 1 by n.
You can tell me the question number na, here. Solve with us.
Okay, just a second.
A to the power.
Solve with Us.
Cannot find the question.
So I'm not able to find it right now. I will tell you next class.
Okay. No, sir. Okay. Thank you then. Yeah.
Thank you, sir.
Thank you, sir.
Yeah. Thank you. Bye bye. Good night.
Good night, sir.
Good night, sir.